of our 1000 element array. So first thing we do before we run off, we're going to copy the array, and then each time we run a sort, we recopy it. But let's jump into the actual sorts, because that's pretty simple. Alright, void bubble sort int array, and it is denoted as an array, remember. So, as previously stated, bubble sort is a very inefficient program. For bubble sort and the next one, selection sort, I'm going to be running both tries and swaps to show you the difference between the two. And we have a temp variable here that is used just for swapping, and a bool variable to keep it in the while loop while we haven't finished swapping yet. So, while swapped is going to run until we don't have any more swaps. First thing it does is set the swap false, and it hits a for loop. This for loop is from 0 to 999. I have it 999 because here, our comparison statement is going to access the current number, the current index, and the next index. So if I had it to 1000, when I hit 999, it would index 999 and then segfault and die, because it's referencing the termination character. So each time we do a comparison, we up the tries, and if it is swapped, we up the swaps, and we flag swapped. And swapping is simple. Element 1 goes into the temp, element 2 goes into element 1, temp goes into element 2. Then we have a kick out of how much it takes. Selection sort. This one uses a pretty basic implementation of a nested for loop, and this is going to make it take n minus 1 times, and each run of it sets the minimum as the index that we have, which would be the first time we'd have it at 0, and then it's going to go through the entire array testing everything against our index, our minimum value. Then if it does find something that's less than, we reset it and set our index to that. So then afterwards we check if we have changed our min, and if we have, we'll swap it out and up the swaps. Now the beautiful thing about this, the maximum swaps is big O n, remember, because it's only doing one swap per full run of the for loop at max. Now for the fun part, quicksort. Remember I said it's recursive, and here's the pivot value and some left and right placeholders, and I'll show the pivot value and the left and right holders. They have big importance in a minute. So the first thing, we set our pivot to the leftmost part of the array, which is called numbers, remember, and we have a left and right parameter. So while we still have numbers to be looked through, it's going to hit another while loop that increments it backwards from the right to make sure that all, any numbers that are greater than the pivot are, until it doesn't, and then if we go all the way through and left is now equal to the right, then we're done. We've sorted all the numbers. Otherwise, we're going to move our current number over onto the left, because we already know that it's less, and bump left up. So now we have the next while loop moves it left, and it keeps checking that the values are less than and incrementing left. And then it's going to kick out. If it's not equal, it switches back, pushes right back one, and then it's going to jump back to the top of the while loop up here. And it's going to check and make sure that they're not equal accidentally, and it's going to run through again and again until they've finished the first round of sorting. And this will take n time and a certain number of swaps. So Then we reestablish the pivot point on the left and reset our new pivot point to the index of the left value. Reset the index up to the left, reset the index to the right, and now we're in the recursive step. Remember, each time there are two recursive steps. First, it checks that the left side is not at the extreme pivot side, and then we check the right side is not at the extreme pivot side. And each time, we're going to make a call to quicksort if that's not the case. With the original array, our new left, and the pivot for the left side, and the same left and the same right, and the new pivot for the right. Remember now it's pivot 1. On the second run for the guy who has to sort the right side, his left, right here, is just to the right of the original pivot point. Now remember, now the original pivot value, is now at a different index point that's sorted, well, partially sorted. All the values on the left of the pivot point are going to be less. And in here, all the values on the right of the pivot point are going to be greater. More on quicksort and possibly how to make it better in the show notes again. So, linear search. I really don't need to explain this, or I shouldn't need to. If you have any questions, shoot yourself. Binary search. This one is a non-recursive implementation. I'm just including to demonstrate the differences between recursive and non-recursive. So, binary search. We have our array, a left, a right, and a key. The key is the value we're searching for. Left and right would be the same thing as before with quicksort, which is just the left and right bounds of it. So it's going to check, make sure that we're running all the way up until the array is of length 1, and then we set our midpoint, which would be just right in between our entirely sorted array, which is very important, and we check it, and if it is, we return it, we found it, and that's midpoint is the index value, that's what it's going to return, and otherwise it's going to call itself on the left. Remember, we have to have a return value of int, so we are returning the value that this would give us. Now, I guess you can understand it as, each courier or desk clerk needs to reply back to everybody else. And well, actually, I guess that analogy kind of works, because each time we go further and further down into the recursive steps, once it's done, it's like, okay, I've got it. Let's return this value. So okay, we've got this, so we're going to return this value, which returns from here. Now, if none of these find it, then every last one of them is going to return -1. So as a whole, it's going to fill up and return -1. So that's it, I guess. The code compiles properly. I have tested it, but I'm not going to show that right now. But I'm going to have some sample output and just a whole ton of more information in the show notes. So hit me up on IRC if you have any specific questions, and later.